So here's a vacuum tube headphone amplifier that I built. Runs on two 9-volt batteries. Got an op amp for actually driving the headphones, but these two little vacuum tubes here are two JAN6418 tetrodes, beam tetrodes. But they are directly heated and they're designed to be ran on batteries, actually specifically designed to operate below 30 volts. But they make an excellent headphone amplifier. Got a little volume knob there, got a power switch, an output jack. Pretty standard stuff, really. Dual gang pot. I have a little trimmer pot in there that is supposed to be the balance between the left and right channels. Doesn't quite work as well as I'd hoped, but I'll get into that in the schematic. These things are actually, it was only like maybe 30 bucks. Of course, shipping is an arm and a leg if you're buying from the United States, but still a very cheap way to experience the tube sound, because it does sound different. When you plug in headphones to this thing, it just, the upper mids sound absolutely perfect. Anyway, on to the schematic. Alright, so this is the schematic of the headphone amp I was just showing you. So, as you can see, beam tetrodes. Actually, it's drawn as a pentode with the screen, the screen grid, or the suppressor grid rather, tied to the cathode. It's actually just a beam tetrode with the beams tied, but electrically almost the same thing. I got a couple of OPA 2134s as the op amps. They are capable of driving headphones, especially with 18 volts across them. They're more than capable. This regulator here is supposed to get, see, these heaters take 1.25 volts each for the tubes, and so I've just series them together and have them go through a regulator. This actually failed in this circuit. I had it just go up and smoke. It's a low dropout regulator. Maybe I'm using it wrong. I don't know. I just slapped a couple of Xaners in there, changed the value of this resistor to something a little bit higher, and so it works, but maybe not as well as it would with a regulator. And the point was to get it so that the voltage in the batteries could drop all the way down to, just a few volts, and this thing would still work. In fact, actually, the op amps would give out before the tubes would. But anyway, the input circuit here has the dual gang volume pot, as you can see, and then a balance pot on the grids of the two tubes. And I thought this was an ingenious idea to get a nice balance control, but it's flawed for two reasons. One, I implemented it with a pot mounted, it's actually not on the board, but it's on the chassis for the dual gang pot. It's for the volume, but the balance is a set and forget trimmer, which honestly needs to be on the panel as well because the user needs to be able to twiddle it. I didn't think it would be, I thought it would literally just be set and forget, so I wasn't really thinking there. But the bigger problem is that the slope of the volume control pots are not linear because they're audio pots. But the thing is, when you wire them together opposite like this, the slopes are sort of inverted, so when you turn the volume knob in one direction, the change in volume is not the same in both channels. In other words, one channel gets louder and the other gets quieter, depending on what direction you go in. And so you have to compensate with the balance pot, which was not supposed to be adjusted that much. So it's actually, sadly, pretty annoying to use. I thought it was a genius idea, but I'm not sure how these get implemented, published circuits, or something that might be sold to the, marketed. I guess they just don't build them that way, but I've seen this in books. I feel like that should work, but I don't know how you would use a linear potentiometer. I don't know. There's little problems with this design, but it sounds fantastic. If you do get the volume set correctly, this thing sounds absolutely fantastic. I have a dip switch as the power switch, but I also put in series a panel mounted switch. Kind of belt and suspenders redundant, but Now, what makes this circuit different than other types of tube circuits, like the Oatley Electronics one, is the fact that normally the screen grid is just tied to the anode. It's basically these tubes are operated as triodes, which isn't bad. I think you get a gain of like 8 with these. I forgot what the gain is as a pentode. It's higher. It's like probably in the teens, I would imagine. The highest you can get out of these tubes is probably 35. I've tried. But if you tie a separate resistor to the power supply going to the screen, normally it's a potential divider, but it can just be a resistor. Usually you have a bypass capacitor to get more gain. So there is some negative feedback going on here because there is no bypass capacitor, but it offers a little bit more gain. And I've noticed if you bias the screen at a higher voltage or a different voltage than the anode, the ringing seems to get better. Because the problem with these tubes is they ring like none other. If you touch them or if you bump the case or something, it's like a ring in like maybe the low kilohertz range, and it's like you don't really hear it with quiet music, but you do hear it a lot when there's quiet passages. And so anything to reduce that is wonderful. If you bias these tubes at the correct voltages, you'll get hardly any ring. That's what I've noticed. This circuit's better. It's not perfect, but it's a lot better than the one you would get from Oatley Electronics. Nothing a whole lot different, actually. Just a standard inverter for each channel, op-amp inverter. Standard stuff, really. There's really not a whole lot to it. Very, very simple, but very wonderful sounding headphone amplifier.